get everybody set up. If you could have your laptops open, head over to this code repository URL. So it's not too hard. It's github.com, my username, and then 2026 Festival of Genomics Workshop. There's some instructions on the README that you can use to follow along. And also, don't worry, like at the beginning, I've got a bit of time planned where I'll talk a little bit, and so you can still have some time to download this stuff. Alrighty, let's get started. Hey everybody, my name is Eric. I'm really thrilled to be here. This is my first Festival of Genomics. For how many of you is this the same first time? Nice. So we're all newcomers here. A lot of us are newcomers here. I think, how many have been here more than once? Okay, yeah. I hope it's a good conference. I'm feeling the vibes there. So a little bit about myself. I'm a data scientist. I work at Moderna. Right now, you can either say fortunately or unfortunately, I've taken on a very high management load, but technology is really something that excites me, and the prospect of tech tools to accelerate how we do our work as data scientists is something that really excites me as well. And that's been a lot of the premise of, that's going to be the premise of a lot of this exploration, this workshop today. So as I was mentioning in the pre-workshop time, if you can, go to this, open your laptops, go to this code repository and just follow the instructions on the README over there. And if you get stuck anywhere, by the way, don't worry. Pair up. Pair coding is great. It's a practice that we encourage amongst the data scientists at Moderna as well. Even in an age of AI coding, like pair coding is still a really important thing. And from today's workshop, we'll also learn how to use AI as a pair coding assistant. Literally pair coding, not doing the work for you, but ideating and working with you, okay? Let me see. Sorry, I lost my train of thought there. I need to make sure that everybody does have the prerequisites for this workshop. So just make sure that you have your favorite coding agent installed on your machine. So if it's VS Code with GitHub Copilot, that's great. If you have Claude Code on your machine, that's great. If you have Codex, whether it's CLI or desktop app, that's great. If you have Gemini, CLI or anti-gravity, that's great. Or if you're like me and you prefer to use open code with some weirdo LLM provider, that's great too. Just make sure your LLM, the LLM that you're using, please use an LLM that is at least Sonnet 4.5 grade or higher. So anything that is roughly the same performance as Sonnet 4.5 for today's workshop will work. I know that Opus tends to be very expensive to use. If you were on the old GitHub Copilot billing, it's 3x tokens. Even now, it's like just 3 times more expensive-ish than Sonnet class models. But really, anything that can do that was tuned after or released after January of this year is going to be a good LLM that you can be using. As for me, I'm using GLM 5.1, but really don't sweat what model at this point. Okay? So just make sure you have your favorite coding agent and that you have the UV package manager available on your system as well. How many of you know what UV is? Okay, it's great. It's a great thing. All right, so if you're still using pip or venv, it's time to switch to UV. How many of you know what Pixi is? Great, because again, if you're on Conda or Mamba or the old stack, it's time to switch to Pixi. I've got a few blog posts. I'm happy to talk with people about this afterwards. Okay, so I wanted to so for the first 20, 25 minutes of this workshop, I'm going to show folks how to use coding agents as part of your agentic data science stack. And to do that, what I'm going to do is I'm actually going to do a live demo, walk through how I would do one of the analyses that I did for an older paper that I had written and that I worked on when I was at Novartis. It's a protein engineering paper. It's one that was very dear to my heart because I was involved as everything from the data person to the data engineer to the DBA admin to the web developer to the machine learner, everything. Did the whole thing with one of my teammates, Arkady, and it culminated in this paper. So we'll walk through that, and that's going to be probably until about noon-ish or something like that, and then or hopefully 11:55, 11:50-ish, if we can do this earlier. Then what I'm actually going to do is I'm going to have everybody at your tables either working solo or even better pair coding with each other to try out to do the same thing on a different data set. And you can either use your own data set or you can use some of the suggested data sets that I've got just to play around. And then what I'm going to do at the end is I'm going to invite folks to talk a little bit about their experiences using some of these agentic coding tools plus Marimo notebooks. All right? Now, final question, how many of you have heard of Marimo notebooks? All right, this one I'm expecting very few people. How many of you use Jupyter notebooks? Yeah, just like Pixi, UV. I think if you're in Python, it's about time to switch to Marimo notebooks as well. It's a very exciting technology. Okay, so, and hopefully also the demo that I'll do here will show that. So I would like you all to follow along. Please go over to, so if you'd like to follow along with me for the demo portion, please go ahead and launch the demo notebook over here by going to your terminal. So open up your terminal, open up your coding agent after forking and installing the repo, and launch the Marimo notebook with this command. It is uvx marimo edit --sandbox --no token, and then notebook/demo.py. Yep.
Where do we find that GitHub repo?
I've been displaying it up at the top. Yeah, so go find it over there. You can just look at if you look for GitHub 2026 Festival of Genomics Workshop, you'll definitely find it under my username, ERICMJL, all right? How many of you have made it to this step where you can launch the demo notebook? Okay, a few people. All right, I'm gonna wait for folks to come up online. Meanwhile, I'm going to show you what you should expect to see, which is you should expect to see a notebook session that looks something like this, what I'm showing on the right-hand side over here, okay? So give me a thumbs up when you've hit this screen. Okay, thumbs up there, thumbs there, a few more. Just let people follow along. Do you need the URL? Because if you have the URL, you will have the README. If you go to this page, you will have the README. The README contains all of the instructions, all right? Any more thumbs up for reaching the state? Okay, I'm just gonna let a few people follow along. Also, Dean kindly reminded me to record this because I'm not sure that this session is being recorded, so I'll have a recording available and you can share the link for folks, all right? Okay, so Marimo notebooks are, so what we're gonna do, sorry, let me think about this. What we're gonna do first is I'm gonna show you how in 2026, taking out legacy tools from our stack, just starting afresh, how can you as a data scientist use coding agents to pair up with a coding agent inside a notebook? A notebook conceptually is really just a canvas, a shared space for you and the agent. That's the way to think about it. So I'm gonna start by going to a file, and if you are inside the code repository itself, you'll find it inside the docs directory /followalong.md. So if I do cat-p docs/followalong.md, you should see something like this document on the bottom left-hand corner, which I'm intentionally not showing too big because it's got a whole bunch of things. And inside there's also a list of prompts that you can follow that I will be following, but I won't be copying verbatim. I'll be typing live for everyone. So with your coding agent open, what I would like folks to do is to go ahead and ask your coding agent, after cloning the repo, to connect to my Marimo notebook session using the Marimo pair skill. I'm gonna hit enter. So you may be wondering, what? Hold on, where's this Marimo pair skill? I sneaked it in. It's inside the repo. You already have it. How many of you know about agent skills? Yes, okay, this is good. So Marimo pair is an agent skill that allows your coding agent, it gives instructions to your coding agent to connect to the live notebook session that's running over here. Now, I believe I have 2 running notebook sessions right now, so it's gonna ask me which one it wants me to connect to. Now, I'm just gonna proactively intervene and go, I want to connect to that one. Okay, so I'm just gonna let it do that. So think about it this, yes, question. On the terminal, oh, you mean in the coding agent? I can. At the same time, if you look at the repo, all of the prompts are also inside the docs/followalong.md file. So go ahead and look inside there as well. They're intentionally there for you to just copy and paste as well if you want to follow along during the live demo session, okay? Cool, so my coding agent has said, hey, we're connected at port 2718, which is the default port that Marimo notebooks run on. What would you like to do with it? So what I'm gonna do is we're gonna ask it to load a data set, right? That's what we do as data scientists. We look at data, and Jupyter Notebooks or notebook sessions are usually the first place we want to take a look at it. I'm going to do something that might break common practice over here, and that is I'm not going to download the data manually to my disk and then load it from a folder and then hard code that path inside the notebook, because that breaks reproducibility, right? If you want your notebooks to be reproducible, they cannot just work on your own machine. They need to work on someone else's machine, and part of making that reproducible is to always pull from source. So this prompt says load. What we're going to do is I'm going to give a bit of context. We are going to work on a protein engineering data set analysis. Load 2 data sets directly from ACS Catalysis. And I'm going to copy the URLs over. EP something. And this one. Use Cloud Scraper and to scrape the files and polars for data frames. 002.csv, I know this one because I published the paper, is a table of enzyme activities, and 003.csv is a table of enzyme enantioselectivities. Just to give it, so while the coding agent is running, I'm going to give folks a little bit of background on what this data set was about, right? We went in and we had an enzyme, it's called IRED. It was part of this thing called Genesis Labs that we were running at Novartis, and IRED was an enzyme that Discovery Chemistry wanted to engineer so that we could do green catalysis. And one of the things that we ended up doing was we did this whole protein engineering campaign on that. And so you can imagine you're going in and you're doing random mutagenesis on this protein. You have the wild type and you're going like, okay, let me hit it with mutations left and right. Sometimes you'll have single point mutations, sometimes you'll have double, sometimes you'll have triple. We did different mutational strategies. So part of some of the mutants were intentionally ordered to be part of a deep mutational scan, where we're generating every possible single point mutation, and some were through pure error-prone PCR random mutagenesis, which gave us like singles, doubles, triples, quadruple mutations all over the place, even frame shifts. All right? Coming back to what the coding agent has done, you'll notice I've been talking, and suddenly there's this markdown cell that showed up. It's called, okay, we're loading this activity data set, and it's got the activity URL, enantio URL, it's fetching the CSV file, and so now we have something happening. It looks like this showed up, but the data frames have not showed up just yet, so just give it a moment. And actually, the coding agent is using the Marimo pair skill to iteratively figure out and debug. So first off, it's using the notebook as a canvas, actively using the notebook as a canvas, and reading state from the notebook, going, oh, okay, did I actually read in the data table? No, it looks like we didn't. Oh, but now we do. So then they have it over there. They got the name wrong. It's not Xiao at all. It's a few other authors. That's okay. So now the activity table loaded, etc. So it's doing its thing. All right. And it actually, because the website blocks bots from accessing it through Cloudflare, so Cloud Scraper is a way that a previous session when I was rehearsing this, Cloud Scraper was a way for the coding agent to go and figure out how to get around this. All right, any questions about this step so far? Not yet, okay. So it wrote a bunch of code, but it didn't show the data frames. I want you to show me the data frames, one cell each. I'm gonna ask it to actually show me the data so I can actually take a look at it, and also so I can show you all live what the shape of the data looks like. So let's give it a moment. It did do this. So you'll notice this is activity data, and Marimo mo.ui.dataframe, it has its own data frame viewer natively inside there that turns out to be interactive. So you can like page through and decide how many rows you want to see per page, for example, like that. I'm going to bring this back down to 10 because of the zoom. Okay, Let me just scroll up a little bit more. And so you can see I've got a lot of columns, but the more important ones are mutation, which is this one. Let me see if I can zoom in a bit. Mutation, which is this column. Mean, alpha, date, hash ratio, count, etc. Not so important. The only one that's important is the mean column for activity. Okay? So when confronted with this data, what might we do? We might say, let's take a look at some let's make some initial plots, right? Let's do some plotting to make sure we understand what's inside here. And so one of the things that I have in mind is that I want to definitely analyze the single mutants first before I go on to analyzing the double and the triple mutants. And so what I'm going to ask for the coding agent to do is give me filter both data frames to keep only single point mutants. I'm just going to copy this one. These are the rows where the mutation column does not contain a semicolon. Then plot for me the joint scatter plot of x equals activity, so this would be mean, y equals enantioselectivity, and marginal distributions on both axes. Only include variance in both data frames. So that might be a legitimate plot that we want to do, because I know that I have single point mutants that were measured for activity, and then we did a sub-selection from the high activity version variance to then do chiral selectivity measurements. So there's a bit of a down selection that took place. So I want to double check and see whether there's a relationship between chiral selectivity and the activity. One of the things that Marimo does is if it doesn't have a particular dependency, it will automatically install the dependency for you inside the environment. And also, I didn't mention this earlier, but Marimo notebooks can carry their own environment. So you actually don't need to have one big, massive Conda environment that might have conflicting Python dependencies inside there. Each notebook can carry its own set of its own dependency set. So that offers a lot of advantages, because when I run the Marimo notebook, I actually get it to have, I run in sandbox mode. We run in sandbox mode to avoid and have that isolation present, okay? So it's iteratively debugging itself, figuring out there's dependencies that it needs based on the dependency chain that it needs to pull in, and it's doing its thing. Let's just see, I'm gonna zoom out a little bit so that's a little easier. So it's running its thing. It's figuring out, okay, I need matplotlib, I need pyarrow, and then it did it in matplotlib. And we have the plot over here, which is extremely familiar. And we'll just make sure we can scroll. Okay, it actually had, this is new for me. I didn't realize, but the Marimo built-in viewer also allows for automatic panning and scrolling on matplotlib plots, which is pretty cool to see. But I think since we're in a web browser, let's actually use Plotly instead. That to Plotly for me, please. Okay, we'll do that. And one of the things that I think is really important as someone who works with data is that the temptation can be, oh, agent, go just do this analysis for me, without actually you yourself looking through the data file, you yourself plotting the data and seeing what's inside there, without you yourself really checking for the quality of data, which an agent really is not tuned for, right? So this mode where instead of me just telling the agent, go figure out which are the most important mutations for me given this data, instead of doing that, I'm actually going more methodically. I'm slowing down now to move faster later, because I can defend every single choice that we're doing. And the way that I'm using the coding agent, I hope you're observing, is that I'm using it in such a way that I gate my analyses plot by plot. One plot tells me, or one plot or one table tells me something that I need to do to move on to the next step, okay? Okay, we're gonna do maybe, in the interest of time, I'm not going to do the empirical cumulative distribution histogram plot, but I do want people to know that if you do try it on your own, if you need to plot the distribution of anything, please do not use histograms. They're horrible. You can lie with histograms. You can hide outliers with histograms. Your bin width is the thing that you can lie with, all right? Instead, if you use empirical cumulative distribution functions, you can never hide a single point of data in your plots. And I have a whole blog post on it. If you're curious about it, you can take a look at it. So we'll skip over this in the interest of time. One of the things that when we do a deep mutational scan, you can imagine, we would love to be able to see what's the activity mapped across positions. So a heat map is a very natural thing for this, where on the x-axis you would have the position on the linear amino acid sequence, and then on the y-axis you might have what is the mutant letter. Okay? And so then for this, what you would want to do is create a heat map where you have the activity, and because we have replicate measurements inside here as well, you actually would have, for certain mutations, you could also imagine plotting the mean activity at a position versus the maximum activity that was observed at that position, right? And so one of the things we might want to do here is to just create this heat map. So let's create a heat map using Plotly, where the x-axis is the amino acid position, y-axis is the mutant amino acid, the color is the value. And I'm going to make a few choices with respect to the color mapping, where the Viridis color scale is for activity, RDBU for enantioselectivity, and there's a reason for that, because the Viridis scale is suitable when you have a value between 0 to 1, whereas RDBU color scale is suitable when you have diverging values, because enantioselectivity goes from -1 to +1. And then what I would also want it to do is to show a line plot of the heat map of the mean or maximum value at each position. So let's get this copied over. I'm just going to end it at color scale. One other thing that I'm going to ask the agent to do is to make this interactive for my eyes. This is not for the people I'm serving yet. This is me trying to, I'm having a hypothesis that I might want to toggle views. And so I want to take advantage of Marimo's tooling to be able to go, oh yeah, okay, let me grab the max value versus the mean value, or let me toggle between the enantioselectivity versus the activity, right? Just to see what it's like. And this is part of the exploratory data analysis step. So we'll let that run for a moment. Okay, and so one thing you'll see here is Marimo also comes in with a bunch of interactive, reactive UI widgets built in. You don't need to install anything, it comes part of the box. And in a moment, we'll start to see some more cells coming out. So while the agent is working, any questions so far? Been taking you on this analysis journey, trying to demo how you would use a coding agent to actually go and do an agentic assisted data exploration. Dean.
So if I'm getting this right, the coding agent cannot see.
It can.
But it's only doing that through the Marimo.
That's right. That's right.
Which is a special power of the Marimo notebook.
That's right. That's right. The alternative for getting a coding agent to write a notebook, let's say it was a Jupyter notebook, would be for it to write the JSON onto disk and then you refresh the page in the browser. But it has no access to the variables that are in memory, and therefore it does not understand what this variable df might be. On the other hand, in this mode, which is Marimo pair code mode, it has the ability to write and execute code inside the kernel itself and grab the output from the kernel back into whatever system it's living in. So if this is a terminal, it'll grab back into the terminal. And then now suddenly the head of the table might be available as part of the context, where it can see the column names, the values, the first few rows, etc.
So if I draw me a line to separate the data.
So you're saying put the median line.
A vertical line. Yeah.
Vertical line, yeah, I can, absolutely. It would read the data, calculate it, and then I'll do it live actually, I like this. So let's try it. On the pair plot, I want you to draw the median lines for activity and our enantio excess. Draw them as dotted lines, vertical, horizontal, as appropriate. We'll give it a moment, and it'll do that in the background. Any other questions? Back there.
I'm getting stuck all the way back up on step 1.
Okay, which coding agent are you working with?
Claude Code.
Claude Code, and which model are you using? Opus. Opus is getting stuck.
It's hitting clay.
Ask it to get creative.
Okay.
Yeah, ask it to get creative. All right, Dean, there's your lines. Right there. So it knew it can manipulate the data and manipulate the plots for you as well. All right, so here is the heat map metric, activity and enantioselectivity. Actually, something is wrong over here. So something is wrong in the plot. In the heat map, it should be way more dense and filled in. The heat map should show activity or enantioselectivity for each mutant at each position. Right now, it's a sparsely populated matrix. Okay, so it's not guaranteed to be correct. This is a pair coder, and it's humanish, as Karpathy says, but it is doing some things correctly. So, for example, it's missing a lot of data, actually. I think I know what the issue is. The issue, yes, it should use the full single point. It found out what the issue was on its own. There we go. That's exactly what we needed. That's exactly what I was looking for. All right, so let me double click, zoom back out. So I have the mutations from A all the way to Y on the x-axis, and I can hover and explore that at any point. And so we notice a few positions are actually cool, and I can interactively zoom in and see what the values are, just as you would with any other plotly plot. Okay, cool. That's all nice and good. Oh yes, question. Yeah. Yeah, so for demo purposes, I'm not looking at the code. In a real world, I would be looking at the code. I'd be studying the code. No, because over time, there are things that you get used to that you know a coding agent is very unlikely to make a mistake on. And those you can kind of let go a little bit more. And then there are over time, and if you intuit, oh, there's stuff that might be outside of its training data, so therefore I want to be a little bit more careful, so then I'll go in and scrutinize the data a little, scrutinize how I do it a little bit more. And that's a really good segue. I promise I didn't plant that. That's a very good segue to the next point, because what I'm going to do next does not exist as a pre-baked package. And so what we're going to do next is we're actually going to try to visualize the activity data on the 3D structure of the protein itself, right? And I know that this doesn't exist as a common practice inside a notebook setting, et cetera, with AnyWidgets, with the tools that I'm going to pick. So I'm actually going to slow down. I'm actually intentionally going to slow down a little bit here. So rather than prompt my way to the exact thing that I want, let's try this. So wouldn't it be nice, because I remember when I was doing this analysis way back when, wouldn't it be nice if we could take the activity data and just plot it on the structure so we can actually just see exactly where the best mutations are? Unfortunately, back in 2020, that was hard, because I'd have to wrangle PyMol, a separate structure viewer, and then learn its syntax, and I didn't have agents to help me with that. But let's try it here. So there's a thing called AnyWidget that allows you to create any widget that you want inside a Marimo or Jupyter Notebook. And so we're going to have it do this. The iRed protein that we worked on, we crystallized it. I still remember the PDB number, it's 70G3. So let's create AnyWidget that uses 3D-mol.js to load the protein structure. Now, I don't know whether it's going to be able to do one-shot protein structure plus the activity. So I'm going to start with just load the protein structure for me. All right? And we'll do that. And then, question.
Yeah. So, I mean,
yes.
So how do we,
Yep.
because of security and everything, you're kind of implementing that. So how does that connection?
Yeah, okay. So that goes into a little bit about the internals of Marimo code mode. Marimo code mode exists as a bash script that lives on your machine. Marimo server is a server process that lives on your machine. And the coding agent lives wherever it lives, but the coding harness lives on your machine. So the coding harness is what allows the coding agent to say, go execute this code. And it's going to execute a bunch of code through the bash scripts that the Marimo pair skill provides. Now, if you actually look inside the repo folder, you'll notice I have a .agents/skills/Marimo pair inside there. You can actually take a look and study what the skill is. It's an open source thing. And so it'll give, and we can talk some more later about the code model as well. Okay? So let's see what it does. Hey, look at that. Now I have a structure viewer in the notebook. All right, that's kind of cool. Let's try this. Now color the protein residues by the same metric selected in the drop-down. For each position that has a single point mutant, color the residue using Viridis, blah, blah, blah. The mean versus max dropdown should also apply here, and uncolored positions in gray. So, and we're asking it to be reactive. So we're gradually building our intuition around the kind of things that we want to make happen. And so in a moment, I don't know if you remember this, but I can actually toggle between activity and mean versus max on the line plot down below versus enantioselectivity, which is over here, all right? So there's the possibility of doing that. And so what I would love to see happen, it's always a risk doing this live because who knows what the coding agent will do. They're stochastic parrots. This will do its thing. It's also missing a few things from the viewer. Actually, now I'm remembering what the structure is. The enzyme kind of looks like two hands that are joined together like that. And on the bottom side, there's actually where the knuckles are. That's where the substrate binding pocket is. And so then that's roughly around where my cursor is located right now. So I'm going to ask it, if we have time, I will ask it to do a little bit more. Okay, any other questions? Okay, if there are no other questions, while this is going, I'm going to speed forward a little bit. I'm going to encourage you all to open up your laptops and get a Marimo notebook up and running. If you scroll down under the followalong.md file, there are a set of data sets that I've plucked out from the internet. Some are Hugging Science, some are Hugging Face Science, and some are, the UC Irvine machine learning dataset repository. So you can definitely because as soon as we're done with this, we're gonna move into a mode where you all are going to be hacking, and then we'll come back together at the last 10 minutes to share what we've learned, all right? So let's give it a moment. It does take a little bit of time. Sometimes it takes more time. Sometimes it one-shots it perfectly. It all depends on the situation. Right now it's going through some errors that it's not, and it's actively debugging. Yes, very good question. There are multiple options. So Marimo has export options as static HTML. That is one option. Secondly, if your Python packages are all WASM, so WebAssembly enabled, you can actually embed the entire runtime as a single HTML file and still retain reactivity. So that is another option. The third option is, because this is a running web server process, if you have a deployment platform at your organizations that allows you to run a Dockerized web server, you can actually then serve up Marimo notebooks on that platform. Heroku way back in the day, or nowadays it would be Railway, if you're in the public internet, or Vercel, for example, if you're, those sort of hosting platforms. Or even Modal. I've done this with Modal. Oh, look at that. Look at that. So we went from rainbow colored to activity colored, right? And then if I were to switch this to, instead of activity, we show the enantioselectivity. It's all reactive down here as well. And you'll notice it's coloring only the pieces that are, for which we have any type of measurement data available. Okay? All right, how do people feel? Is this a whole new world for you all, or is this exciting, or is this scary? What's your feelings on this? Yeah, okay, use thumbs. How are you feeling about this? Okay, so sounds like I'm seeing a lot of thumbs up. So what I'm gonna do is, let's launch, because of time, interest of time, let's launch into hack mode. I will make myself available and walk around if you have any questions. You can talk about stuff. For those of you who did manage to get UV installed, if I could ask for a little bit of help from you all to help folks at your table or neighboring tables for technical support, that would be amazing. Or otherwise, you can always approach me, and I'm happy to talk about things, all right? So let's have a bit of fun. Go and hack with people who are at your table or at the next door table, and work on something that is a data set that you're interested in, either the ones that I've provided or something that you've got on your machines that you'd like to work on, and then we'll come back and do a little bit of discussion at the end, okay? Cool, go for it, have fun.